One of the things that I think is very important as we continue on in this era of COVID-19 is to try to understand what is happening, how it happens, every possible element. And obviously many eyes are on the science and medical community to come up with a vaccine. We've heard and talked about the vaccine for this thing maybe since we first heard about COVID-19, and I thought there'd be some value in bringing in an expert and kind of walking and talking us through the vaccination process, the creation of a vaccine, maybe even just what a vaccine is. And I found somebody. She is the professor of pharmacy at the University of Wisconsin School of Pharmacy. She herself is a pharmacist. It is Mary Hayney. Good afternoon, Mary.
Good afternoon. Thanks for having me.
Well, I appreciate you coming on very much. And like I teased and like we talked about yesterday off the air on the phone, I really want to make this just kind of a vaccine 101. So consider me consider all of us freshmen walking into your class on day one, okay?
Okay.
From a vaccine perspective, can you just, in layman's terms, tell us what a vaccine is, maybe how it's different from a cure per se, but the value of a vaccination, the value of a vaccine, and then we'll get into some of the particulars.
Oh, sure. Thanks. A vaccine is a way of tricking your immune system into thinking that it's already had the infection and preventing future infections. So as opposed to treatment, which is you're already sick, a vaccine is just for prevention. There's a variety of strategies and preparations that we use for vaccines. We can use modified organisms that have been modified in the lab. And the examples of those are measles, mumps, rubella, and varicella, or the chickenpox. And those are live vaccines. They are administered by injection, and they undergo even limited, like the viruses themselves, the modified viruses will replicate, and your immune system thinks it's got the infection and makes an immune response to it. Very, very vigorous, probably lifelong immune response. Other ones we used killed pathogens. We use parts of pathogens. We use some techniques of recombinant DNA, similar to the techniques that is used to make human insulin. So, new technologies are being worked on for the coronavirus vaccine too.
Mm-hmm. So because you hear this when it comes to getting the flu shot, is a vaccine, is the flu shot the virus? Is there a part of the virus that is in that dose as part of that fooling the body process?
Mm-hmm. For the example of the influenza vaccine,
right.
The influenza vaccine does, in fact, most influenza vaccines.
Sure.
Not all of them, because there's different preparations, which is cool because we have then a variety of options for immunization. But for the routine influenza vaccine that millions of people get every year, that does actually have a little bit of piece of the virus in it. But it is purified. It's certainly not the virus. It can't replicate. It's in no way, shape, or form alive. So, the people who commonly say can't get the influenza vaccine because it gives me the flu.
Right.
No.
No. Okay. So obviously everyone is eager for the vaccine for this thing. Everybody is, especially, I just feel like this week we have heard more speculation as to a timeline of how quick and how long and all this stuff. But before, I don't know that I'll ask you to speculate because that would be putting you in a rough spot. But take us through why most vaccinations in general take so long to be developed, years and years and years. I mean, really from the get-go, we were told that don't expect anything for, 12 to 18 months as it pertains to this particular potential vaccine for COVID-19. But how come it takes so long? What's happening behind the scenes?
Well, the first step, of course, is to identify the pathogen, to identify it. And that happened very quickly with coronavirus. It was a matter of essentially a few, I don't want to say days, but probably say a couple of weeks once they identified that there was this coronavirus causing disease, it was sequenced. And the genetic makeup of the virus was made public. Even before it left Wuhan, China, that we knew what the genetic sequence of that virus was. That's very helpful, and that's something that's new and revolutionary, can speed up vaccine development. Think back. We think of Edward Jenner at least as the father of modern vaccinology. He didn't even really know viruses existed then. So, a contrast. But anyway, what happens is the pathogen needs to be identified. You need to figure out what is a protective immune response, and what part of the immune system and what specific response of the immune system protects you from infection. And so that's key because how else will you measure whether or not you're making an effective immune response? Then you have to develop the vaccine and figure out what's the best strategy for it, for developing it, and then you give it to just a few people. And that phase 1 trial, which is just a few typically healthy people, you give it to figure out what's the best dose, what's the best route of administration, how is it best given, and then of course you can see if something really bad happens. But hopefully that doesn't. That has been. But it's certainly possible because first time it's given to a person. Mm-hmm. And then next you go and give it to a few more people. That's a phase 2 trial. Then you're looking to get that immune response, and you measure the immune response in the lab. And then the phase 3 trial is where you actually try to prevent disease. So you give some humans vaccine and some humans placebo, and you measure which group gets more, is there a difference in how they get the infection? And that would then be protection from infection if the vaccine group has fewer infections than the placebo group.
And there's
usually is usually is what is the definitive proof that a vaccine works.
And so the 3-phase process,
mm-hmm.
there really is no knowing ahead of time how long the vaccine will take in each phase before it advances, because in and of itself, each phase is basically a trial and error process. Is that fair to say?
Each phase is an experiment. And you can usually get some idea of how long it'll take based on how frequent, like for the phase 3 anyway, the phase 3 trial, which is the trial where you compare and you want to see how well does this protect against infection. You can usually tell how long it will take. You can make an estimate how long it'll take, because what you do is you estimate how often people actually get this disease. And so, if people get this disease really, really frequently, then you might be able to do it over a couple of years, waiting for people to get because you have to wait for people to get who would naturally get the infection anyway. The people who got placebo, with how often do they get the infection? So it can take years to prove that this vaccine is effective.
Wow. You're good to hold through a quick break. We're talking with mm-hmm. Mary Hayney, pharmacist and a professor of pharmacy over at UW-Madison. When we come back, I'm going to get just your reaction to some of the reports this week, I think including Dr. Fauci saying maybe something by the end of this year, early next year, and what you're hearing, because I think we hear a lot from a lot mm-hmm. of people as it pertains to vaccinations, but you are in touch with the scientific and the medical community, the inside word, as it were, as to just how optimistic you are and how optimistic your colleagues are about finding this vaccine. Mary Hayney is our guest. We'll continue with more in just a moment. Stick around. I'm Scott Warras. You've got WTMJ. Mary Hayney is our guest right now. She is with UW, the School of Pharmacy, and a pharmacist herself. Mary, before we get to the timeline and the optimism, hopefully you can share some optimism. We hear about the virus evolving, mutating. I don't know if that's too dramatic a term or not.
That's right.
And if that is the case, how do those coming up with a vaccine for it, how do you stay ahead of the virus, or how do you keep up? Are you not constantly playing catch-up with the virus as it changes?
That's a great observation, and that's exactly what happens with influenza. So the influenza vaccine is reformulated every year, and with viruses changing in and out. Now, the coronavirus that is SARS-CoV-2, which is the name of the coronavirus that is causing the pandemic, has been relatively stable, genetically stable. And so from that point of view, there's been pretty good optimism. But of course now it's circulating in a naive population, so there's very little pressure for it to change either. So if eventually it does seem to mutate more, which coronaviruses have been known to do, then we will be in a tighter spot with the vaccine. So far, I mean, it's hard to know. All the vaccine trials are in very early stages, but vaccinologists, those who develop the vaccines, have been pretty. The news coming out is pretty optimistic. As the clinical trials move on, of course, the successful ones make the news. And of course, the successful ones also make the press releases in order to make the news, too.
Right. No, yeah, absolutely. So with that is a great segue. So, I mean, if you wouldn't mind, what does your gut tell you? What are your colleagues talking about, in the scientific and in the medical community? Obviously, there's optimism from press releases and podiums across the country. But what is the science telling us right now in terms of the optimism for America?
Yeah, I'm optimistic, and I want to go beyond America and for the world. Because any vaccine, and as well as therapeutics that we develop for the COVID-19 pandemic, needs to go worldwide. We clearly see how small the world is because we had a pandemic from a coronavirus that was first identified in China, and it was just a matter of weeks before it was global. So we need to be able to figure out a way to distribute a vaccine when it becomes available, and I'd like you to notice that I said when.
Thank you. Duly noted, Mary. Thank you.
Yeah, so I'm really answering your question. Because I think we really clearly need to develop a strategy for worldwide and global distribution of the vaccine.
Which takes me to the other question that I've had. I mean, think about it. You have the time will come when some lab somewhere in our country, in another country, somewhere on the globe will say, "Eureka! We've got it. It's passed through phase 3. Here it is in this, I don't know, vial, maybe? I don't know. Here is the vaccine." Okay, to which I will say, great. How are you going to get it to the rest of the world? Which is a massive logistical nightmare.
Exactly.
How do you approach that?
Most people who are working on the vaccines have also are working with either within their own labs or with partners to figure out a way to upscale, because you need to scale up production immensely. I mean, imagine that the vaccine manufacturing process is going to have to go into overdrive on this. It's not like we have empty vaccine factories sitting around. Vaccine manufacturers keep their vaccine manufacturing lines full. So, this is going to require a big investment, and that's actually what's happening. Is worldwide, there's been a huge investment in developing this vaccine.
Has there ever been anything on this scale in terms of a worldwide, like you said, effort, one team here?
Yeah, no, and I'm not aware of one.
Sure.
but I don't think I would find it difficult to believe. And now, please know that multiple vaccines are being developed. Early on, I would say a month ago, I heard it was well over 100 vaccines were being developed, and then of course there were a few that were leading, or further along in the development process. I don't want to call it leading because I think that's misleading, but further along in the development process. But that will be exactly what we need. Is we're going to need a lot of options. One, because you can probably develop or manufacture and distribute if you're using multiple different platforms on which to do it. The other one is, of course, the obvious, which I should have stated first as the first reason, is at least then we have options in case one fails, or for those who fail, we have a backup plan. We have a bench.
Yes, absolutely, and that is, it's. We're going to have you back on maybe multiple times, Mary, to continue the progress of this as this journey continues. I appreciate the information. I know the folks listening right now do as well. We all really appreciate your optimism, because it is heartening to hear it from somebody in the business, so to speak, rather than, like you say, from a press release or whatnot. So Mary Hayney, pharmacist herself and professor of pharmacy at UW-Madison, greatly appreciate the time. We'll do it again soon. You've been a valuable resource, and continued good health to you and the family, okay?
Oh, thank you so much.
Soon. You've been a valuable resource, and continued good health to you.